Hello and welcome to Let's Code an Indie Game episode 8. This is the series where we go through the tools and techniques needed to get started with indie game development. In this episode we're going to think about window size, resolution and how we make sure our game scales nicely. But first let's review what we did last time. So if we switch to our code, and let's just run the game straight away. So we can see we can change between our rooms, and each room has its own set of entities which it looks after, and if we move back into a room we can see we remember what happened to all of those entities and they just pick up where they left off, which is very nice. So let's remind ourselves how all of that works. So if we look at our room.lua class and we check out the update method, we can just remind ourselves that the room now goes through every entity inside of it and makes sure it gets updated, and when it gets updated it passes in the GameState object, and the GameState object or the GameState class is what lets our entities make decisions about where other entities are, what's going on in the game, so they're a bit more interesting, they can move based on other things, not just themselves. We still have our code in here that changes the room we're in by calling methods on map, which is also passed into update based on where the player is. So we go to the next room if the player is all the way to the right of the screen, we go to the previous room if the player is all the way to the left of the screen, and also when we create our room we pass in the list of entities which we want the room to look after. And for now we're still just setting the room to a random background color so we know when we've changed rooms. So let's take a look at how rooms are created. So if we remind ourselves, inside of map.lua we have this create room function, and this just creates a new list of entities in random positions, and then it passes that list of entities into the room. One change we should make here from last episode is when we create the map we always make sure there's at least one room inside of it. Our code would just look nicer and it would be sort of less surprising if we just used our create room method to generate the first room instead of doing it by hand. So now all of our rooms are the same, it's nice and consistent. Okay, let's think about this episode. I'll just throw up diagram. Right, so the challenge we have with doing a pixel art game is if we draw our pixels at the actual size of the size they would appear on the desktop, they'll be very, very small, because a lot of pixel art the style of pixel art comes from a time when you had less pixels on the screen because you had less computing power to deal with all of those pixels. But we don't have that restriction, so instead we're going to take the size of our window and we're going to create sort of virtual pixels inside it. And all that means is that for every pixel on our desktop we're going to... actually, let's flip that round. So for every pixel in our game we're going to use maybe 5 pixels or 4 pixels from our desktop. So we're not going to be drawing the actual pixels, we're going to be scaling them up by 3, 4, 5 times to whatever looks good for us. And this will give us sort of a virtual resolution of 270 pixels by 180 pixels. And that's if we run our game in a pretty standard resolution, say 1080 by 720. So where do those numbers come from? Well, let's take a look at the next diagram, or scribblings. So we can see here that the Legend of Zelda on the NES, so the original Zelda, that ran at about 256 by 224 pixels. I think the NES actually did 256 by 240 pixels, and Zelda just had some lines at the side. Shovel Knight, which is a newer pixel art game, that runs at about 400 by 240 pixels. So that's really what we're aiming for, that kind of resolution. So we're going to take our window size and we're going to resize our window so it's 1080 by 720, because that gives us 1080p resolution. It means our game should look nice on any consoles or on any tablets if we decide to port it there. So we're just going to take that resolution and we're going to divide it by 4. So when we deal with our window, we deal with 1080 by 720, but when we actually deal with the pixels inside of our game, we deal with 270 by 180, and everything is scaled up for us. Let's think about how we do that in the code. Okay, so first of all, it's probably easier to show this by way of example. So let's jump into our sprite, and if we cast our minds back to the sprite episode, or the episode where we made the sprite class, we just passed in 10 and 10 as the scale values because we wanted to make it easier to see, really. So if we get rid of 10 and we just use the default scale, which is 1, and run our game, we can see that everything is very tiny. So this is what I was talking about. If we draw our game at our default pixel size, everything is very, very small. Hard to see, we can't really tell what's going on. So instead we want to have the window scale for us, or scale up the graphics for us based on the size of the window and the size we would like the game to be. So let's create a new class to manage that. So inside of graphics, let's make a new file. Let's call it view.lua. And as always, let's just wire up the module. And add a create function. Local instance is empty table, and we return the instance. Okay, so what do we actually need to pass into our view in order to have it switch between our window pixels and our game pixels? It would be useful if it knew the size of the window, and we could get this from just calling love.graphics. And actually, yeah, let's go ahead and do that. So, but we do need to tell it what our virtual pixel resolution or what our target resolution is. So let's just say game width and game height. Then inside of this guy, we can just wire it up. Instance game width equals game width. Instance game height equals game height. And now we can introduce a function for getting the scale of our game. So let's just call it scale function. It's an instance method, so it takes self. And we can just return love.graphics.getWidth and divide that by self.gamewidth. So that should give us the width of the window divided by the width of our target, how many pixels we want to actually deal with. And if we divide the width of the window by the number of pixels we actually want to deal with, it will tell us how many pixels are in each virtual pixel. And all that means is that inside of our sprite, if we come down here, pull in our view using require source.graphics.view. And for now, just to test it, let's create it inside of the draw method, although eventually we do want to move it. But for now we can do local, let's just call it v is view.create, and we know we wanted to use 270 by 180 as our actual virtual pixel resolution. And then we can pull out the scale, so v.scale. And if we use our scale in here and in here, and I'm just going to check we wired everything up inside of our instance.scale equals scale. So now our pixels are slightly bigger. They're not as big as they were, but that's okay. I'm trying to pick a size that works well for the game. And I think this is kind of nice. You can see everything that's going on, maybe a bit bigger in the final game, but we can always play with the numbers a bit more when we have some more artwork in there and can get a better feel for how things look. So a lot of the initial setup that I'm doing is based around the idea of let's keep things pretty loose for now, because we can always come in and change our numbers later. Great, so that's one way of getting the scale. And it works, but the challenge is, do we really want to pass in these two numbers for every time we try and draw a sprite? Do we really want to be scaling it ourselves? It would be much nicer if we just told Love's graphics engine that this is the scale we want to use, and then everything else just goes ahead and draws at that scale. So let's change our view so it works in that way. So what we'll do is we'll create another function, and we will call this function, let's call it inContext. And the reason we're calling it inContext is because we're going to create in Python, which is another language, another programming language, you generally call these context managers. I'm not sure if that term exists in Lua, but we're going to go ahead and call it a context manager anyway. This takes a function, and the job of this function, or the job of the inContext function, is to come in, do some setup, then we call our function. So we can pass functions around just like any other argument, and they only get called when we add the open and close brackets on the end. So we're going to do some setup, call our draw function, and then undo our setup. Again, and what this just makes sure that everything in our game is drawn in the same, has the same graphics transformations applied to it. So let's think about what those graphics transformations look like. Well, we can just do a love.graphics.scale, and in here we can just use our scale function. So go ahead, local scale equals scale, and of course we need self as well here because it's an instance method, so we can just call scale on self. Then down here we can go ahead, use scale and scale as the arguments. So we only get the scale from the width, which means our height doesn't affect the scale of the game, but we're going to assume that the window is going to be rectangular. The aspect ratio is going to remain pretty much the same, and we can we can come back and make that nicer a bit later on, but let's just do the minimum we need to get started for now. So love.graphics.scale, and we want to be able to undo our setup as well, so it's important to include a love.graphics.push here, and finally a love.graphics.pop at the end. So if we remember back to when we introduced these functions, push will create a new it will create a new transformation for us, or a new graphics context, and pop will undo that graphics context. And a graphics context is just the set of instructions we want love to remember before it starts drawing. So what we're saying is, when you call draw, before you call draw function, scale up all of the graphics to the scale we want, and afterwards forget that the graphics should be scaled up. Okay, let's see if it works. Before we do this, scale no longer needs to actually be a public method on this function. We can just leave scale inside of this class. So instead, let's expose inContext. Okay, so that means inside of our sprite, rather than grabbing the scale this way, we can just go ahead and get rid of our scale arguments. We can rewrite this as view inContext, and we just pass in what is called an anonymous function. So this means it's a function, but we're not going to assign it to anything like we do with draw. We're just going to create it and use it as an argument. And all we need to do inside of this function is our drawing. Okay, let's see what happens. Great, we are still scaled up. One thing to notice is we're suddenly a lot faster, and this is because when we set our speed values, we were assuming the graphics system was unscaled, so we'll need to go back and tweak those as well. And the other thing is we can go a lot further now before we change room, because although our graphics or our sprite graphics are scaled, but our room graphics are not scaled. So that's something else we need to go in and change. Okay, so if we dive into our GameState class, let's assume that everything is going to use the same view to start with. So we're going to make view an argument of our game state so we can share it just like we share things like the map and the player object. So down here we'll say view equals view. And then when we draw things, we're going to need to start passing in the view from self. So that will be self.view at this point. Self.view and self.view. And so now we need to actually make use of our view. So where does that happen? So sprites get drawn inside of entities.draw. So actually let's just trace this through from map.draw, or sorry, from GameState.draw. So the first thing GameState.draw does is it calls map.draw. So let's take a look at map.draw. Here we go. So draw currently only takes self, so let's make, oops, not game, let's make sure it takes view as well. And here we can start to use our view in context. Start the function, end the function, make sure we close the argument as well. Oops, I actually wanted to only indent these bits. There we go. Okay, but in our context here, actually, sorry, no, we did not want to do that. So we only want to use our context when we actually draw something. So that was a very good example of what not to do, and I'll explain why very quickly. So what we don't want to do is double the scale of the screen. So we only want to use our context when we actually draw something, and map.draw doesn't do any drawing itself. It just well, I guess it draws the room we're in on the screen. It prints to the screen, but it doesn't actually draw the rooms. Room.draw draws the rooms. So we're just going to pass view in here. Then if we go into room, now on room.draw, we actually do some drawing. We actually call love.graphics, push, pop, and all of these other things. So we can get rid of our push and pop because that's done for us inside of our view. And here we can actually do what I was trying to do inside of map.lua. So view in context. We create an anonymous function. Make sure we end the function and close the brackets as well. Okay, so now when we draw our rooms, they should be scaled. And the next thing we want to do is pass in view to our entities as well. And then inside of entity.lua, we can go ahead and again pass in the view, and here we see we call sprite.draw. So again, we don't do any actual drawing here, we just draw the sprite. So let's go ahead and add view to this as well. So now if we finally get to our sprite, we know that this will take view as its second argument. We no longer need to create the view here. Instead, we can just use view in context here. Ooh. So now let's just quickly go back to map. Sorry, not map, to GameState. And let's just check. Well, self_player.draw uses uses our entity and our sprite, and we know we've already updated those. And entity also uses entity draw also uses our sprite class, which we've updated. So hopefully, no. So again, we made a lot of changes at once there, so it's probably to be expected that something isn't quite working. Room.lua line 7, attempt to index local view a new nil value. If we go to room line 7, So this probably means we're not passing in view, so who calls room.draw, map does, so we are passing in view here, but do we pass view in to the map from GameState? Of course, we need to actually create a view in our GameState. So let's in here do local view is require source.graphics.view, and now we should be able to just pass view in as our second argument to the game state. So view.create, and we know we want it to be 270 by 180. Aha! And now finally, if we go back into our rooms, and we change our room width and our room height to be 270 by 180. Ooh, that was interesting. Oh, of course, we also need to change our positioning code, which is inside of map, I think. Yep, so when we call previous room and next room, we should eventually get this value out of the view, because otherwise what just happened there will keep happening. But for now, let's say 270 here. Okay, and so now our game is all scaled by the view class, and we don't have to worry about scaling inside our individual drawing classes, which is or drawing methods, which is quite nice. And as we add more transformations to the game, this will become really useful, because it just lowers the number of things we need to think about in the when we actually draw things. Like when we draw a class or an entity, we really only want to worry about drawing that entity. We don't want to worry about the basics, like how do we scale the room. And another nice thing to notice here is that our room value at the top, that's not getting scaled because we didn't draw it inside of our view, which is what we want. We don't want this room counter at the top to be enormous. So finally, we can also see that because we're using our width value to scale the screen, we have this black line at the bottom because our resolution doesn't currently match our virtual resolution perfectly. So let's fix that. So if we create a new file inside of our base folder, call it conf.lua, and this file needs to live next to main.lua. So as long as it's in that folder, that's fine. We can create a function called love.conf. And what this function does is it sets all of the config values that we want to set before the actual game starts. So things like the size of the window. So unlike love.load, which gets run after the game has been created and starts, love.conf runs before that. So let's set our width to 1080, because that's the value we used in our diagrams, and let's set our window height to 720. Okay, and now if we run the game, 1, it's bigger, but 2, we see our room fits perfectly inside of our game once again. Okay, so I think in our next episode we're also going to look at how we have rooms which are bigger than the screen, and how we can have a camera that follows the player around, and to do that we need the code we've written in this episode. I'm trying to get to the point where all of our graphics code is set up, or at least there's, the minimal amount of graphics code is set up, so it makes sense to start doing a bit of pixel art as well and make our game look a bit nicer. So expect that in the next couple of episodes. Thanks very much for watching, and a big shout out to anyone who has liked or subscribed to videos, and especially the people who've been giving me feedback. I am taking it on board and trying to improve the series that way as well. I hope you're enjoying it. Have a great day, and goodbye.